I've always wanted to build a remote controlled Chinook helicopter, but I can never justify buying one helicopter for the price of two. So I'm going to adopt a bicopter configuration style aircraft into a Chinook. A bicopter configuration aircraft isn't anything new. In fact, my vertical takeoff plane that I built quite a few months ago is essentially a bicopter when it's hovering. Now, bicopters are inherently unstable due to there only being 2 points of lift, and some people compare it to sitting on a two-legged stool. So for the bicopter to be stable and controllable in flight, the points of lift, or the motors and propellers, must be able to pivot. Because this aircraft is going to look like a Chinook, the motors will sit one in front of each other, which means the least stable axis will be the roll axis. So the motors will have to pivot about the roll axis for roll stability, similar to how my vertical takeoff plane controlled the pitch axis. So the plan for the main frame structure of this aircraft is to use this aluminium spar. I got this from Hobby King. I think it's 12.5 by 12.5 millimeter box section, 60 centimeters long, weighs about 55 grams. It's super tough, like I can barely bend that. So I might end up drilling holes in it to save some weight. And the plan is to join sections of this together using 3D printed brackets. In fact, I might be able to put a design up here of what my plan is for what it's going to look like. This frame structure will create a sturdy platform for all the electronics to be mounted to, and hopefully allow me to test fly the Chinook before building a nice looking scale fuselage around it. I've tried to match all of the angles of the aluminium spars and 3D printed parts to fit within a Chinook looking scale fuselage, so the rear motor is slightly raised up and angled forwards, as well as the front motor slightly raised forwards. The front set of landing gear wheels slightly longer, so that it has a nose up tendency like the rear one. And yeah, I think it's time to warm up the printer. So whilst the parts are printing, I cut out the correct size aluminium spar lengths and pre-drilled all the holes for bolting to 3D printed parts. The 3D printed parts are printed out of PETG plastic, which I was given from 3D Prints UK. I used PETG for its high strength and also ease of printing, and I'm quite impressed with the way that this filament prints so far, so it'll be a good test of the strength of this frame once I've put it together. I've designed the 3D printed parts to be a very tight fit inside these aluminium spar sections. That's so that the friction makes sure there's a really tight fit, and I don't need to apply any glue or anything. Then I'm just going to put a bolt through the ends there and also there, just to secure it so that if the friction does come loose, it doesn't come out. So I'm going to get on with hammering this all together, and we should have a frame by the end of it. Okay, there we have the main structure of the Chinook, or the Chinook, depending on how you want to call it. Either way, it's a helicopter. I've also mounted the motor pivot points, the rear and at the front right there. And then these are the motor mounts, where they will mount onto there. I'm currently waiting for some brass bushings, which I'm going to cut, which will be greased for a good pivot point. But they haven't arrived in the post yet, so we're going to get on with mounting the landing gear struts. Because the parts that fit the aluminium sections together were quite tight, I couldn't get them all in all the way, so I might have to re-drill those holes through the 3D printed part just to secure it. As well as the landing struts, I've also 3D printed the flight controller mount. This will hold the board which does all the gyros and accelerometers to control the throttle of the motors and also the pivot of them. These are the brackets which will hold the servos, which will control the pivot of the motors, and they'll bolt like that. And then here is the servo. I'll post the spec of the servo in the description below. This will bolt onto that bracket and sit right there. This is the flight controller designed for racing drones, and you can program it to run pretty much any kind of multicopter or drone that you wish, and I'm just going to use it in a bicopter configuration setting for this setup. So I've just quickly soldered up the servo to the flight controller and also soldered up a 5-volt regulator temporarily, and I've just done this just so that when I plug this in, the servo will center to the center point of what the flight controller is told it to, This way I can bolt it all down and I know that I don't have to take that servo horn off again. So I'll quickly plug that in. And there we go, the servo is now centered. So I'll do that to the rear servo and then start mounting the motor and the push rods. So I've soldered up both servos now to the flight controller and it's time to mount the motor mounts. The brass inserts arrived in the post, which I've just pressed fit into the 3D printed plastic part here. And I'm using the brass inserts because I'm going to use M3 bolt as an axle for the pivot, and the brass will wear down slower than a 3D printed part would. So I'm just going to find the correct size bolt and mount it onto there. So I've put a bolt through the motor mount and motor pivot now, so it pivots nice and smooth. There's zero play, however the bolt that I had was slightly too long, so I'll take that off and cut it down at a later point in time. But I'm really happy with the way that that pivots, nice and smooth. And the next thing to do is to make the push rods that will go from the servo horn here up to the motor pivot here, so the servo will be able to move the motor mount. I'm going to use this aluminium, I think it's 1 or 1.5mm diameter rod for the push rods to connect the servos to the motor mounts. And I'm going to do that by just bending a few different shapes into them, which will then hook inside the servo horn, like so. Then once I know the right length, I'll bend them to then join into the top of the motor mount, and it will look something like this. So now the servo can control the motor mount. So I've finished mounting the push rods to control the motor pivots, and I'm just going to plug it in and see if we can get these motor mounts to pivot. So now if I move my transmitter stick, it does indeed pivot. Now because it's also got a flight controller which has gyros and accelerometers built into it, if I pick it up and rotate the whole thing, you should be able to see the motor mounts correcting, which is pretty cool. So I think it's time to mount the motors and solder up all of the main power electronics for the thrust. So I've soldered up all of the main power wires and I'm going to set up my laptop now and we can check if everything's working. And I think my laptop just ran out of battery. So if I plug in the flight controller to the computer and click connect, I should be able to get everything to power up. And then if I power up the servos and the speed controllers and the motors with the battery, now if I rotate the stick, should tilt the motors, and if I flick the arm switch, it also spins the motors. So it looks like everything's working. Oh, let's get into a bit of a vibration shake. So I need to adjust the PID gains inside the gyros. So I've just finished off tidying up the wires on this. Just using a few cable ties, I've just tied them to the main structure of it. But it still looks a bit messy, but once the Chinook fuselage is built around it, it won't look so bad. From my air-powered propeller video, I asked whether you'd want to see projects in parts, and the majority of people said yes, they would rather see weekly videos. So I'm thinking of doing maybe 10-minute videos every week, so I can go more into depth of how I build certain things, rather than just doing a quick time lapse and music time lapse, and you miss a lot of the information. And that way, if you get bored of watching the build, you can always miss out the next part if you wish to. But if you want to see more details, I will go into the extra details of, how I 3D print the brackets and all that kind of stuff that put these projects together. So my next step is to find some propellers that will suitably match this motor and battery setup, and hopefully next week I'll be test flying it. And if it flies, I'll be building a Chinook fuselage around it, which should make it look pretty cool. So yeah, stay tuned for that. If you enjoyed this video, please leave a thumbs up. If you're new to my channel, then please click subscribe. And if you really enjoy my projects, it would be much appreciated if you could support me on Patreon as well. The link will be down below, or there'll be a box right here. Thanks once again for watching, and I'll see you next week. Goodbye.